Alright, so similar length, area and volume. When we talk about mathematically similar, it means one shape is an enlargement of the other, and obviously we're going into 3 dimensions and surface areas and things like that. So the thing we've got to remember is, obviously, scale factor is what we have to multiply to get from one thing to another. If it's linear, it's just times in by the scale factor. If it's area, times by the scale factor squared, or the length scale factor squared. And if it's volume, times in by the length scale factor cubed. Right, so let's click in with this. Cylinder A and cylinder B are mathematically similar. The length of cylinder A is 4 centimeters and the length of cylinder B is 6 centimeters. So to get from A to B, 6 divided by 4 is 1.5. So then, if we want to do the volume, it's going to be 1.5 cubed. So we've got 80 times 1.5 cubed. That gives us a volume of 270 centimeters cubed. Two cylinders P and Q are mathematically similar. The total surface area of cylinder P is 90 pi centimeters squared. The total surface area of Q is 810 pi centimeters squared. Sorry, centimeters squared for both those. The length of cylinder P is 4 centimeters. Work out the length of cylinder Q. So, area scale factor, and this is, sorry, that was A to B. This is going to be P to Q. So we're going to do 810 divided by 90 with some pi's involved. Equals 9. So our area scale factor is 9, therefore our length scale factor is going to be square root of 9, which is 3. Therefore our, length is what we want. So the length of P is 4, so 4 times 3 equals 12 centimeters. Now we're going to go and want to work out our volume scale factor for the next part. Sorry if you can see that. The volume of cylinder P is 100 pi. Work out the volume. So our volume scale factor is going to be 3 cubed, the length scale factor cubed, which obviously is 27. And we are going to end up doing 100 pi times 3 cubed, 27. 100 pi times 3 cubed equals 2,700 pi. Question 3. Two prisms A and B are mathematically similar. The volume of prism A is 12,000 centimeters cubed. The volume of prism B is 49,125 centimeters cubed. The total surface area of prism B is 9,728. Calculate the total surface area of prism A. I'm going to assume that is. So we want our scale factor. We're going to be going from B to A. So we've got 12,000. Whoops, got it off. 12,000 divided by 49152. Which gives us, sorry, this is our volume scale factor. (125 over 512). Oh, I think that will turn out quite nice actually. It looks horrible at the moment. I'm going to keep it as a fraction. Notice it's less than 1 because B is bigger than A, so we're going to be getting smaller. Our scale factor has to be less than 1. So now we're going to have to work out our length scale factor by cube rooting this. So shift square root button, because that will be the cube root, our answer, and we get 5/8. And therefore our area scale factor, which we'll need for the surface area, is this squared, which is 25/64. So then if we take the surface area of prism B, 9728, and we multiply that by 25/64, we get 3,800 centimeters squared. Really important you don't do any rounding there, otherwise all sorts of strange things might occur. Okay, so diagram not drawn accurately. Two cones P and Q are mathematically similar. The total surface area of P is 24, the total surface area of Q is 96, the height of P is 4. So we are going to go from P to Q. We are going to end up with a area scale factor, which is going to be 96 divided by 24. The height of the cone P is 4 centimeters, so we're going to want our length scale factor. Well, we would need that anyway if we're going to work back. So that's the square root of 4, which is 2. Work out the height of the cone. 4 times 2 equals 8 centimeters. Now we're going to need our volume scale factor, so we'll take the length scale factor and cube it, so that's 2 cubed. We've got the volume of cone P is 12, so we're going to do 12 times 2 cubed, which gives us 96. Okay. Question 5. Diagram not drawn accurately. Two solid shapes A and B are mathematically similar. The base of shape A is a circle with a radius of 4 centimeters. The base of shape B is a circle with a radius of 6 centimeters. The surface area of shape A is 80 centimeters squared. Work out the surface area of shape B. So we are going A to B scale factor, length scale factor, because we've got a radius which is a length. We are going to do 8 divided by 2, which is 2. Now we're going to need our area scale factor, which is going to be 2 squared. The surface area of shape A is 80, so we're going to do 80 times 2 squared, which is 320. Now, the volume of shape B is 600 centimeters cubed. Work out the volume of... So we can work out our volume scale factor of A to B, which would be 2 cubed. Because we're going the other way, we could work out all of our scale factors B to A, but we can just divide by this, or we could use its reciprocal. 2 cubed is obviously an 8. The reciprocal would is 8. The reciprocal would be 1/8. But we are going to do either 600 divided by 2 cubed, or 600 times 1 over 2 cubed. Either will give us the correct answer. I just go for the division usually if I've got this far into the problem. 75 centimeters cubed. Okay, diagram not drawn accurately. Two cylinders A and B are mathematically similar. The height of cylinder B is twice the height of cylinder A. Length scale factor of 2. The total surface area of cylinder A is 180. Calculate the total surface area of cylinder B. Okay, because cylinder A, the height of cylinder B is twice the height of cylinder A, well, we want to go from A to B. If we think about, if we said this had a height of 2 and this had a height of 1, if we were going to work out a length scale factor of A to B, it would be 2. Yeah, that's it, sorry, yes. So therefore our area scale factor is going to be 2 squared. 180 times 2 squared. 720. Oh, hold on, we're missing something. Centimetres cubed. Because it wasn't on the answer line, we've got to make sure it's there. Sorry, couldn't see that last bit, I'll just leave that there a moment for you. And I think that is us done.